know the black lines of PA, PB, PC are in tension or pulling? I have no idea, and I don't care. All I want to do is express them, and then let the math tell me if I chose the right directions or the wrong directions. If C has coordinates of 4, -3, 0, and P has coordinates of 0, 0, 12. Step 1, complete. Step 2, write the position vector for all of these. R, PC first, XC minus XPI plus YC minus YPJ plus ZC minus ZPK. RPC vector is 4I minus 3J minus 12K. That's step 2. Step 3 says, hey, instantly calculate the magnitude of this, which is 13. Step 4 says, find me the unit vector. Take the position vector, divide by 13 to give me the unit vector, and then multiply step 5, the force times the unit vector. Well, I'm going to do steps 4 and 5 together and say FPC vector is magnitude FPC times 4I minus 3J minus 12K, all in divided by 13. That's going to give me 0.3076 FPCI minus 0.2301 FPCJ and minus 0.9231 FPCK. There is my FPC in terms of IJK. The goal in any 3D problem, get me forces in IJK format. Did I accomplish that goal here? Yep. Now I got to repeat it for P, B, and PA. So next, I'm going to do RPA. That's XA minus XPI plus YA minus YPJ plus ZA minus ZPK. Now, had you chosen PA to be pushing up against P, then this would have been XP minus XA, YP minus YA, ZP minus ZA, and that's the only difference. RPA vector is 0I. Please notice I put a placeholder. Do I have to do that? No, I don't have to do that. But I do because my mind says first term I, second term J, third term K. If I don't put that 0, I'm going to think first term I when it's really supposed to be J. Especially in the heat of battle of a test, you're going to make that mistake. I've seen it over and over and over in the 30 years I've taught this class. It happens. Okay? So I place a placeholder. Plus 5J minus 12K. Magnitude of PA is 13. Therefore, FPA vector is magnitude PA times 0I plus 5J minus 12K. Divide this by 13. That makes it 0 FPAI plus 0.3846 FPAJ minus 0.9231 FPAK. There is PA in terms of IJK. Is there anything I'm doing here that is out of chapter 3? No! This is all chapter 2, section 7, 8, somewhere in there. I ain't doing anything fancy. I'm repeating what I learned in chapter 2. I got to do this one more time. RPB. XB minus XPI plus YB minus YPJ plus ZB minus ZPK. RPB is minus 4I minus 3J minus 12K. Instantly, square, square, square. I'm going to take the square root. Freaking frac 13. Therefore, FPB is magnitude PB times minus 4I minus 3J minus 12K. Divide this all by 13, which shall give me what? Give me minus 0.3076 FPBI minus 0.2308 FPBJ minus 0.9231 FPBK. I now have all forces in IJK format. Yes, the 5, which is parallel to my Y, is 5J. The 12, which is acting straight down, is my K. And the 4 is in the I. So I'm not worried about those. Any questions on what I did? Again, all of this mumbo jumbo here is nothing more than chapter 2. Chapter 2. I ain't done anything in chapter 3 yet. It's all chapter 2. Who's not with me? Anybody not with me? Am I doing anything that you're like, wow, what the hell is he doing? No. I'm doing what we've done in the past. Nothing new. Now, I'm going to apply equation for equilibrium. Now, I'm going to do chapter 3. Here comes chapter 3. I'm going to say, hey, some forces in the x equals 0, positive coming out of the paper, because that's the coordinate system I'm dealing with. All that's saying is, hey, take all your i's and put them together. Okay, that's 0.3076 FPC. That's plus 0 FPA. That's minus 0.3076 FPB, right? Plus 4 equals 0, or you could say equals minus 4. Either way, doesn't matter, same thing. So these are all the I terms put together. Some forces in the Y equals 0, positive this way. Now it's all the J's. Minus 0.2301 FPC plus 0.3846 FPA minus 0.2308 FPB plus 5 equals 0. Or equal to minus 5, either way. Some forces in the Z equals 0. Positive straight up. Put your K's minus 0.9231 FPC minus 0.9231 FPA minus 0.9231 FPB minus 12 equals 0. Those 4, 5, and 12 are the implied loads. Again, you can take the 4, 5 and put them on the right-hand side. And now what do I have? Statics is done. You have no more statics to do. It's over. Now it becomes a math problem. You have three equations, x, y, and z, and three unknowns, P, A, P, B, P, C. Solve. Now, this is why I suggested to you, please get yourself a TI-84, because I know they can handle solving a system of simultaneous equations. And when we get to chapter 5, you're going to have 6 equations in potentially 6 unknowns. So it's much easier if you do it using the calculator. What?
I saw a different method being used. Do you still recommend just for consistency's sake?
Different method for what?
For the use of algorithms?
What method are you dealing with?
I could be
Are you
wrong.
creating your own method?
I think what I was seeing they were doing was they were taking the distances, they would take the distance that you're given with a force, and then they would take the distances, the other distances, and they would add them up, which is the magnitude of that last distance. And they were using those distances on the triangle as the slope. And they were using that to multiply by the force given to get the projection of something like that. And I was wondering if you just recommend.
Do you understand it?
Now.
I have no idea what you just said. That's the honest truth. If you'd like to show it to me, I would gladly listen, because I'm always willing to listen. If there's a quicker, easier way, by all means, let's do it. I have no idea what you just said to do. Now, did it work? Does it work for all situations? Or is it working just for the one particular problem that you were doing? I don't know. I have no idea. So if you want to show it to me, and if I think it's a legit process, shit, I'll teach the class that process. I don't really care. So, I know this works every single time. Okay? That's why I'm showing you this process. Alright, so if I solve, I should get FPA equal to minus 13 kips. FPB equal to 6.5 kips. FBC is equal to minus 6.5 kips. These are all kips. What's the minus sign tell me? Hey, doofus, you guessed wrong on tension, tension, tension. Only one of them is in tension, and that's PB. The other two are pushing up against joint B, so they are in compression. Anytime you push up against a joint, that member has got to be in compression. Anytime you pull on a joint, that member is in tension. Can PA and PC be cables? Can PA and PC be cables? No, because cables can't push. They can pull, they can't push. So those have to be solid members. 2x4s or whatever. The other one, PB, you can put a cable in there and tighten it up to 6.5 kips. Based on the way I drew my free body diagram, my free body diagram showed pulling, pulling, pulling. These are all in tension. Okay? Because they're negative, that means reverse the arrow of the PA and PC, which means they got to push. Once they're pushing on a joint, that's compression. Where's the missing link here? Mystery. I like mystery. You know I'm going to give her shit. So when you see her, tell her Nora's going to give you shit for not showing up. I know she knows. But I'm still going to give her shit. Any questions on this? Yeah. In terms of? If this was on a test, this would never be on a test like that. Why would this not be on a test like this? Huh? No.
It's too easy.
What's that?
It's too easy.
No, not necessarily because it's too easy. What did I tell you I was going to do to you? How many ways can I give you information in 3D? How many ways are on this problem?
One.
Would this be a test question?
No.
No. Because it's missing double projection and it's missing alpha, beta, gamma shift. So this would not make it as a test question. Yeah. I would say you'd write 13 kips in compression, 6.5 kips in compression, 6.5 for PB in tension. I would like for you to tell me that so I know you know what the hell you just calculated. It's one thing to calculate, but it's another thing to interpret what the hell the calculation said. Yeah.
So, like, on a question similar to this.
Yeah. Yeah.
Are you asking for the magnitude of the forces or the forces themselves?
No, the magnitudes of the forces. 13, 6.5, 6.5.
Okay.
Other questions? Speak or forever hold your peace. All right. Let's turn to the next problem. The next problem shows you exactly what the hell might occur on a test. Because on this one, notice double projection here, alpha, beta, gamma here, and coordinates here. So all three are in this one, which would be similar to what you would have on a test. Now, would this be a test question? Hell no. Why not?
It's too easy.
It doesn't incorporate, yeah, now it's too easy. It doesn't incorporate more shit. What the hell do you mean by more shit? There's more concepts to be put into the problem to make it uglier, to make it test you on other concepts other than an equilibrium problem with the 3 ways to give information. And you'll see what I mean when we go further along the line. Well, you could put a spring. All right. So F2 is really easy. I'm going to do that one first. F2, you notice the coordinate system. It is Kepler's. So F2 is really F2 cosine 135I plus F2 cosine 60J plus F2 cosine 60K. This is your alpha, your beta, and your gamma. There's your beta, there's your gamma, and there's your alpha. So that was easy. F2, piece of cake, here it is, minus 0.707 F2I, plus 0.5 F2J, plus 0.5 F2K. I express the first force in terms of IJK. Next force, double projection. Here is the line to nowhere. How do I get there? Well, I'm going to say F1 cosine of 50. Wow, we call it the line. Wow.
Can you zoom in, please?
No. Yes, I can. Is it that bad? Let's see, zooming in, here you go. Is that better? You guys want a lot. Shit. Good God almighty. All right, so the line to nowhere, we call it the line to nowhere because it's not an X, not a Y, not a Z. It's not parallel to the X, Y, or Z. It's sticking out in space someplace. So if I want to get it to the X, project this force to the X, what do? I take this and swing it cosine 30. Where do I land after I swing cosine 30? Along the X. Great. So what you're telling me is this F1 has to be F1 times cosine 50 cosine 30 I. Next, I'm going to have cosine 50 sine 30 j. But this puts me right here, so this is the opposite to 30. That puts me on the negative j, or y, so I've got to put a negative on that. Which, by the way, a lot of you, what did I tell you the number one error is? Sines. So on question number, whatever, quiz number 3, when you did the double projection shit, a lot of sign errors. Those of you that got 740 as the resultant, guaranteed you had a minus sign error. Because the answer was 703, not 740. Okay? Now, all I have to do is say sine of 50 puts me on this line, which is parallel to z. So this is plus sine 50k. So F1, when I rearrange everything, F1 will be 0.556 F1I minus 0.321 F1J plus 0.766 F1K. There's F1 in terms of IJK. I'm going to call this 0, 0, 0. I'm going to call it O. I'm going to call this point B. And now I'm going to say ROB vector is XB minus XOI plus YB minus YOJ plus ZB minus ZOK. Well, that's going to be 6 minus 6, 6I. 6 minus 0 is 6I. 6 minus 0 is another 6I. Or 6J. And then minus 3 minus 0 gives me minus 3K. Magnitude of ROB is 9. Therefore, F of 3, or FOB, whichever way you want to call it, is equal to F3 times 6I plus 6J minus 3K, divide that by 9. That's going to give me 0.667 F3I plus 0.667 F3J minus 0.333 F3K. What are these numbers, by the way? 667, 667, and 333? What are those? Those are the direction cosines. So if I were to take 0.33 negative, take the cosine inverse, what would I get? Gamma. Right? That's what I would get. Now what? Well, now I'm going to do what I did before. Again, all of this mumbo jumbo was chapter 2. Now comes chapter 3. Some forces in the x equals 0, positive coming out of the paper. That says, put all i's together, 0.556 F1 minus 0.707 F2 plus 0.667 F3, and now the force is minus 10 equals 0. Some forces in the y equals 0. Positive upward. That says negative 0.321 F1 plus 0.5 F2 plus 0.667 F3 minus 9 must equal 0. Some forces z equals 0, positive straight up. 0.766 F1 plus 0.5 F2 minus 0.333 F3 minus 6 equals 0. And I've reduced myself down to 3 equations, F1, F2, and F3, with 3 unknowns. 3 equations, 3 unknowns, solve. Well, if I solve this for F1, F2, F3, I'm going to get F1 is equal to 9.66 kilonewtons. F2 is 6.19 kilonewtons. F3 is equal to 13.5 kilonewtons. That's when you put it in your calculator and you say, solve this set of equations for me. Questions? Yeah. The answer is no. Go ahead. Did I not? What do you think the numbers in X, Y, and Z are? Negative 10, negative 9, negative 6. Where do you think I pulled those out? Not out of a hat. They were given to me in the statement of the problem, so I incorporated them, right? You with me? Who's not with me? Yeah.
So how did you solve it?
It's a math problem. I'm not here to teach you math. I'm here to teach you statics. You should know how to solve 3 equations and 3 unknowns. If you don't, that's why I'm suggesting get a TI-84 or something equivalent that will solve a system of simultaneous equations. That should solve it. Don't ask me, how do I plug it in so I can solve it? Because I don't have one of those, therefore I couldn't tell you. Best thing for you to do is Google it. How to use a TI-84 to solve a system of simultaneous equations. I'm sure it'll tell you. I'm sure there's a YouTube video on it. But again, I don't use that. I do it by hand. Well, how the hell do you do it by hand? I take these equations and manipulate them. There's lots of ways to solve system of simultaneous equations. Gaussian elimination, method of substitution, Cramer's rule. There's all sorts of ways to do it by hand. I just usually revert back to substitution method. So I get this equation and solve everything for F1. Then I take that F1, dump it in here. Then I'd solve this one for F2, dump it back in here. Now I have one equation, one unknown. And then you solve. So it's nothing more than a fancy method of substitution. Just a little harder because it's 3 equations, 3 unknowns, rather than 2 equations, 2 unknowns. All right, so that ends chapter 3. I'm in and out of chapter 3, being done. Now I'm going to go back, grab chapter 2, section 9. Then I'm going to go to chapter 4 and grab the first section, second section, 4.2. Because if you read, you'll see 2.9 is a dot product, 4.2 or 4.3 is a cross product. So I'm grabbing stuff that I call vector algebra and putting it into one lecture. That's why I skipped 2.9. So if you go to page 43, you'll see the first topic is dot product, which is chapter 2, section 9. So the notes are in your pro copy booklet. You don't have to do anything. All I did is I took chapter 2, section 9, took the important stuff out of there, dumped it into the pro copy booklet. So I'm reviewing vector algebra. Now, some of you already know dot product, cross product. That's great. I'm happy for you. How many have not done dot products, cross products before? Good. That's awesome. Except me, I will assume nothing. You said you've seen it, you've done it, blah, 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 and I'm going to assume that you forgot it. Which is probably a good assumption on my part.
What page is that?
So I make sure everybody's on the same level ground, and everybody gets the same shit. And if you already know it, then you're going to take it from the back and bring it to the front because you're going to be using it. So dot product, also known as the inner product, also known as the scalar product. Here's the definition. This is what mathematicians tell us a dot product is. A dot B, it's not A times B, it's A dot B, is the magnitude of A, magnitude of B, and the cosine of the angle in between the two vectors. So you see vector A, vector B, and there's an angle between them. The dot product is magnitude of A, magnitude of B, cosine of that angle. That's going to result in a scalar value. Laws of operation, notice cumulative. It is A dot B dot B dot A. It doesn't matter how you do it. Order is immaterial. Distributive law. Multiplying by scalar, you can do whatever you want. Multiply the scalar times A, then dot it with B. Multiply B times the scalar, then dot it with A. You can dot them and then multiply them by scalar. It doesn't matter. Unit vector formulation. I'm pointing out something that's very important because you're going to be dotting things. You got to know what happens when you dot. I with I, J with J, K with K, and other combinations like I and J, I and K, and so forth. Notice, I dot I is 1, J dot J is 1, K dot K is 1. Any other combo is 0. Where the hell did you pull that out of? Simple. I went back to the definition and said I dot I. Magnitude 1, magnitude 1. What's the angle between I and I? Well, what's the cosine of 0? So I dot I is 1. What if I said I dot J? 1, 1, cosine of the angle between the two, I and J. 90. What's the cosine of 90? That's how you know what I dot J is, J dot J, and so forth. So any combo of I's, J's, and K's are all going to be 0 other than the unit vectors with itself is 1, JJ 1, KK 1. Now what happens if I have forces, and I'm using A and B, but this could be a force and another force, and I wanted to dot them. The only thing that survived is I with I, J with J, K with K. So you have AX, BX, AY, BY, AZ, BZ. What if I wanted to square it? Well, I'd have AX squared, AY squared, AZ squared. That's what the mathematicians tell us. Right? Now, I have a question for you. So we have this wonderful dot product. Great! I'm happy. What the fuck does it do for me? I'm an engineer. I'm practical. Mathematicians go, ooh, yeah, lovely. I don't care. If it doesn't do anything practical for me, I don't want to learn it. Well, I do want to learn, but I want to be able to use it. How the hell can I use it? Well, turn the page. You'll see 3 uses of the dot product. The first use. Hey, what if I have 2 cables and I want to know the angle between the 2 cables? Well, if I have the position vectors of, say, RAB and RAC, if I want to find the angle between the 2 cables, dot RAB, dot RAC, divide by their magnitudes, take the cosine inverse, voila, I got an angle. That might be useful, because I might be looking at something and it's 3D, and you're looking at it going, it looks like it's 90 degrees, but I'm not sure. Well, I can be sure if I do this. Find the actual angle. It'll tell you if it's 90 degrees. Second method. What's the second thing I can do with this dot product? Hey, I can project. Give me another name for projection or a synonym. Do you know what a synonym is? And I'm not talking buttons, not synonym buttons. What's a synonym for projection? Well, if I give you F and I give you an angle, you can always say F cosine of the angle gives me X. Great. But what if I give it to you in 3D and say, hey, and I don't tell you find it on the X, but find it on some arbitrary line. So find me the component of this force on line AB. Arbitrary. How do I do it? According to that, number 2 on page 44, it says, hey, find the unit vector of the line AB. Dot it with the vector that you're trying to project. Wow, that's pretty powerful. Right? What's the last thing you see there? A use of the dot product. What? Orthodontist? That's a guy with teeth. No. Orthogonality. Give me a synonym for orthogonality. Perpendicular. In other words, hey, I can test whether two vectors, two forces, are perpendicular to each other. If they are, then their dot product has to be 0. Well, that's fantastic. So I've got 3 freaking uses that I can make use of in engineering for the dot product. I like that. It's practical. I love practical. All right, next. This is now chapter 4. Remember, chapter 4 is when we change models to rigid body. What the hell is a rigid body? What's a rigid body? Hey, it's a system of particles that has a center of gravity, has size, has shape, has everything except they can't do what? Can't deform. That's why you go from statics to mechanics of solids, you mechanicals, or civils go to mechanics of material. Same class, same book, same everything. One's taught by the mechanical, the other's taught by civil. You say, well, why the hell do we have 2 classes on the same campus basically teaching the same thing? Answer, money. It's pretty simple. Money. The mechanical department wants their money for teaching that class. Civils want their money for teaching EGN 3331. That's why. They use the same book. Everything's the same. One's taught by mechanical, one's taught by civil. It's that simple. Comes down to money. We want your money in the civil department, and they want your money in the mechanical department. Okay? Other than in the civil, we emphasize a few things in mechanics and materials that are different than the emphasis in the mechanical department. So it's the same material, but we emphasize certain things more than they do. That's really the other reason for 2 different classes, other than money. Cross product, also known as the vector product. Notice the definition, here it comes. A cross B is magnitude of A, magnitude of B, and the sine of the angle in between. Notice this. I want you to underline this, and we'll come back to bite you in the ass here. The direction of the vector C, which is the result of the cross product, is perpendicular to the plane of A and B. Got it? Underline that, because in a few days, I'm going to go back to this damn underline. C is perpendicular to the plane that contains A and B. All right. From a practical point of view, A cross B is the same as the area of a parallelogram with sides A and B. Now, is laws of operation, is cross product commutative? No, it's not. Please note. A cross B does not equal B cross A, however, it does equal to the negative of it. So what you're saying here is order matters. Now, if we're discussing it, why are you discussing the cross product? Especially if we're discussing it in chapter 4. Why? Well, if you read the first 8 pages of the Pro Copy book, like I told you to, you know why. Why? Why am I discussing cross products? What's the big deal? Why? Yes! Go back to the first 8 pages. It said moment, tendency of force to create a rotation about a pointer axis, calculated as force times distance, where distance is the perpendicular distance, or R cross F. Oh shit. So I can calculate moments by doing a cross product. Yep. I just need an R and I need an F. The F is what's causing the rotation. So I gotta teach you how to calculate a cross product. That's why we're discussing cross products. Distributive law holds, that holds, notice, I cross I, J cross J, K cross K is 0. Again, go back to the definition and you'll see why. Now, what about if I wanted I cross J or K cross I? What happens then? Well, that's when I use this little device. If I want I cross J, I, go to the next letter J, the next letter would be K, and since I'm going counterclockwise, that's a positive K. That's how that little device works. Okay? Why is counterclockwise positive? Because counterclockwise obeys the right-hand rule. If I have I here, curl to my J, notice these are counterclockwise directions. My thumb points in the K direction. But in the process, I created a counterclockwise rotation. Why? Because it obeys the right-hand rule. That's why this is positive this way. If I say K cross I, K, next letter over is I, next letter over is J, but I'm going counterclockwise. No, I'm still going counterclockwise. So this would be J. What if I said I cross K? I cross K, next letter over is J, but I'm going clockwise. That's a minus J. Get it? Now, we're going to get everything in terms of complements, especially in 3D. Great. How do I calculate a cross product? Again, you got to understand, I do everything by hand. I know some of your calculators can do cross product. I'm happy for it. Do it, by all means, using the cross product of the calculator. But for me, I do a determinant that says, hey, first row, IJK. Second row is the first letter of the cross product. Third row is the third letter of the cross product. Now, you tell a mathematician, hey, do me that cross product, and they'll say, okay, I gotta eliminate one row, eliminate one column, do a 2 by 2. Eliminate another row, eliminate another column, do another 2 by 2. And eliminate another row, another column, do another 2 by 2. That's called the method of cofactors. I don't remember the method of cofactors, and I do this. I extend the first 2 columns over, and I do diagonals. So this is the first diagonal, that's the second diagonal, that's the third diagonal, and then I go negative, 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 going the other way. That's how I do my cross products. Again, I don't use a calculator, I just do this. So if you look, that's AYBZ. There it is, AYBZ. There it is right there. And now you group all your I's, J's together, and you'll see there's your I, there's your J, there's your K. Do I want you to memorize that? Hell no, I don't want you to memorize that. It's not the purpose. Okay? What I do want you to see is there is no X
in the I component. There is no Y in the J component, and there is no Z in the K component. Why? Because if this is parallel, then the cross product is going to be 0. So your AX, your BX, they're going to be parallel to the I, so they won't appear in the I component. Okay? You with me? Why are we doing this? Because moment is equal to R cross F, which means I'm going to set up a determinant that looks like this. Rx, Ry, Rz, Fx, Fy, and Fz. And then I'm going to do that determinant to figure out what the moment is in 3D. You with? That's the whole purpose. The last part of the last vector algebra that you're going to need is what's known as the triple product. Please note, these are all triple products. So A dot B times C, A dot B cross C, A cross B cross C. These are all triple products. Now, triple products can be scalars, can be vectors. Depends on how you arrange the dots and the crosses. Okay? So they could be either or, scalars or vectors. Dot products are always scalars. Cross products are always vectors, but triple products can be scalars or vectors, depending on the arrangement. Notice A dot B times C, this is going to give me a vector. A dot B cross C, that's going to give me a scalar. And A cross B cross C is going to give me a vector. So again, depending on the arrangement of dots and crosses and so forth, triple products can be scalars or vectors. What?
For that first function, doing A dot B, we're just multiplying by vectors with crossing every product.
I'm just taking A dot B, should give me a scalar, 2, and then times the vector C. All right, what's important to us? What's important to us is this one. You're going to see this one in chapter 4, section 5. Chapter 4, section 5 is going to use the scalar triple product. Somebody tell me, what is chapter 4, section 5's title? Title. Oh, did everybody hear that? Moment about a specified axis. Okay? So the title of chapter 4, section 5, chapter 4, section 5, moment about a specified axis. Oh my goodness, that sounds ominous. Holy shit, I'm scared already. Let me put it to you in a different term. Same shit means the same crap. Project a moment, which is a vector, onto a line. Same shit, but doesn't sound as ominous as moment about a specified axis. Yes? It means the same thing. How do I calculate a moment? How do I calculate? Oh, before you answer that, how do I project any vector onto an arbitrary line? How do I project any vector onto a line? Do you know how? What?
Will it make sure the direction of that line?
Yes. One of the uses of the dot product was projection. How did we project based on that dot product shit? Unit vector of the line dotted with the vector. Yes? Keep that in your mind. How do I calculate a moment? R cross F. So really, what you're doing in chapter 4, section 5, you're going to say, hey, it's A dot B cross C. A is going to be the unit vector of the line, B is going to be the R, and C is going to be the F. That is projection of a moment onto a line. That is all that's in chapter 5. Holy shit, that's it? Yep, that's it. Okay? So what you're going to do is you're going to say A dotted with B cross C. That's going to be a unit vector of the line dotted with R cross F. Well, that is M. That's it. That's all chapter 4, section 5 is. It's an application of the dot product, where the vector happens to be a moment rather than a force. That's it. How do I calculate a moment? R cross F. That's it right there. R cross F, and then you're going to project it onto this line by dotting it with the unit vector of the line. Easy peasy. Okay. So now this is how you calculate that sucker. A dot B cross C. You with me? That's going to be a unit vector. That's going to be R. That's going to be F. Notice the first line is the vector A, which would be the unit vector. The second line is the second, which would be your R. And the third would be your F. That would be here. You extend the same two columns over, the first two, and do the diagonals. Same thing. And that should give you a number. Just like when I say F100 cosine of 30 gives me Fx, which is 86.6. It's a number. You're going to get a number here. Okay? Testing name. Please. All right. Pay attention. If you're sleeping, wakey, wakey, so you can hear. Blah, 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 I don't care. Tell me, E. Hey, find me the angle between force D and C. So there's force D, there's force C. I'm asking you, find me this angle. Do you know how to find an angle between two vectors? Yeah. How? FD dotted with FC, divide by magnitude of F, magnitude of C, take the cosine inverse. That's just an application of the dot product. We just discussed today. Notice it's on the test. It was on the old test. Yeah? You with me? Who's not with me? So what did I do? I put this problem together and I said, you know what? Let me grab chapter 2, section 9, angle between two vectors, and put it on there. That's all I did. I'm telling you what I do on tests is no secret. And yet I still get people that fail. How the fuck do you do that? You didn't study.
It's hard.
It's not hard. You're making it hard because you didn't study. That's why. Okay? And I'm telling you what I'm going to. Can I borrow it? Is that a pencil? Okay. Let's go a little further down the road. Question number 3. Hey, tell me the component of F3 about line DE. Do you know how to do that? Unit vector DE dotted with F3. Done! How hard was that? That's the second use of the dot product. Second. Let's go a little further. Find me the moment of the force about DE. Chapter 4, section 5 says, unit vector DE dotted with R cross F. Application of the triple product right there. We just did that today. Did it make it on the test? Yes. Why do people say Noah's tested from hell? Because everything is on the goddamn test. Everything. There isn't anything that's not on the test. I'm telling you what I'm going to do to you. It's like somebody says, stand there, look, see this fist? I'm about to punch your ass. And you say, okay, go ahead. That's what you're doing when you fail. You're saying, okay, just punch me. Really? I'm telling you what I'm going to do to you. Notice, chapter 2, section 9, all things came into play. How to find the angle. That was in question 1. Hey, how do I find a component along a force? That was in this one, question 3 of the test. Chapter 4, section 5. Project the moment onto a line. That was in there too. Look, moment of the 200-pound force about line DE. Chapter 4, section 5. We just covered it today with the triple product. You with me? Who the hell's not with me? I am not hiding anything from you. I'm telling you what's coming your way. It's not a surprise. Not a surprise whatsoever. Will the diagram be the same? Hell no, the diagram's not going to be the same. The content, it can't change. It's statics. I can't change the content. I can change the diagram, make it a little uglier, give you all 3 ways of giving you information in 3D. What are they? Alpha, beta, gamma. Hey, wait! Do I have to give you all 3?
No.
Why not? What? What is the identity?
Where cosine gain is squared plus cosine gamma squared equals 1.
Ah, wonderful. What's the next thing I can do to you? Double projection. Hey, does this problem have a double projection problem in it? Oh shit, you recognize the double projection. Right? So here, I'm going to swing this cosine 60 and land where? Land right there. What is that? That's the line to nowhere. Why do we call it the line to nowhere? It's not X, it's not Y, it's not Z. It's not parallel to the X, Y, or Z, is it? So now I have to swing it again. If I swing it cosine 30, where do I land? Where do I land? I land on a line parallel to what? Z. What's the first thing I tell you to do when you have a 3D problem? Check the coordinate system. Because if I change this to Y, Z, X, now what you've landed on is the X component. So if you're just thinking it's the same coordinate system that's in the Hibbler, because Hibbler uses one and only one coordinate system, and I told you what can Nora do? Use any coordinate system as long as it obeys the right-hand rule. Right? If it obeys the right-hand rule, I can throw in any coordinate system. That's why I tell you in a 3D problem, always check the coordinate system. Well, you're just doing that to fail me. No! I'm doing that so that you pay attention to details. That's what you're going to have to do in the real world. If you don't, you might have catastrophe on your hands. That's the problem. So yes, if you don't catch it, okay, so you didn't catch it. But I'm trying to train you to catch the details. Right? That's the whole purpose of flipping the coordinate system around. I told you, please pay attention to the coordinate system. So if I flip it around and you don't, all your answers are going to be wrong because you're projecting on these X, Y, Z's and you're thinking it's Hibbler's coordinate system and it's really not. In the testing manual, I show you a problem where it is not a standard X, Y, Z, but it's still right-handed. Yes? Okay, whose pencil did I get? Here, thank you. Okay, whose book did I get? There you go. All right. Let's do a couple before we bolt out of here. Again, I assume nothing. I assume you all said, oh, I know dot products and cross products. I know, okay. We covered it because I want to make sure everybody's on the same footing. And also, if you do know it, it's probably way back in the cobwebs of your brain. Let's dust it off and bring it to the forefront. So I want you to do A dot B for me. A dot B. Nothing fancy. Why am I doing A dot B? Well, you're going to have to do A dot B if I ask you to find the angle between two vectors, between two forces. Real quick, just do A dot B for me. What did you get? Shh. I didn't ask you yet. What do you get? A dot B. Give me some. Work it out real quick. You should have it already. You got it? She's got it. You got it? You're still thinking, how the hell do I do an A dot B? Didn't you raise your hand saying that you didn't know how to do A dot B? Oh. What do you got? Nothing. He's still working on it. Good God, it doesn't take that long to do an A dot B. You don't even need a calculator for that. I'm going to use the calculator. Don't do it. What'd you get for that? No, don't tell me. Let me see.
Nope.
Okay. What'd you get? Okay, what'd you get? Still working on it. I already checked yours. What do you got? I checked yours. Okay, nice. What do we got back here? A dot B. What'd you get?
This,
How many got? 11I, 4J, minus 0K.
like the,
Everybody get an IJK? What'd you get? For A.
I just don't.
You got a scale. What'd you get? You got 9. How many got 9?
9 what?
Fantastic. How many put IJK? Be honest.
You got IJK
He just threw you under the bus.
I'm still working on it.
He just threw you under the bus. How many put it in a determinant? IJK.
I'm still working on it.
You won't tell me anyway. What'd you get? 9. The answer is 9. You don't know how many times I get people writing me IJK for that number, for that value. Okay? It is a number. It's a scalar. You don't get IJK. My Monday, Wednesday class gave me like about 10 people that wrote IJK. The answer here is 9. What is it? 2 times 9 plus 4 times, remember this is 0J, 0 plus a negative 3 times 3. Remember, I's with I's, J's with J's, K's with K's, any other combo is zip. Answer here is 9. What'd you get for B dotted with C? Huh? What'd you get? 3. How many got 3? Anybody got anything different than 3? What'd you get?
I got 0.
You got 0. So I've got 0 and 3. Anybody got a different number than 0, 3? How the hell did you get 0? I can't multiply. Wait. I'm going to love this answer. Go ahead. How did you get 0? Because I already know why you got 0.
I think I took the I mixed up my components. I got the I component
Don't
from
you know that I
the
wrong,
with
but
the I
look
component
at
with the 4.
What did you multiply together? B times C.
Yeah, I multiplied 3K to negative 1J.
Ah! Did everybody hear that?
No.
Repeat what you just said. This is important. What you just said. I multiplied 3 times what?
The 3k component to the negative 1j component.
So you dotted those two together.
Correct.
You know why you did that? Because you didn't have a placement holder for 0j. What did I tell you to do? Always place a placement holder. What happens if you don't? Exactly that. When you said 0, I said, I know exactly what you did. I know exactly what you did. Okay? No, it is 3. What about A cross B? Well, that's I, J, K of A. 2, 4, negative 3. B, 9, 0, 3. Extend the 2 columns over. Do this, that's 12I. Do this, that's minus 27J. Do this, that's 0K. Going the other way is minus 6J. Going this way is plus 0I. Going this way is a minus 36K. Sum these suckers together, I'll have 12I minus 33J minus 36K. Agreed? And we'll finish this up on Thursday and start moments on Thursday. That's done.